There are various types of wiring diagrams used in the HVACR industry. We'll explain how to read a schematic wiring diagram and what the various symbols represent and how they function. Wiring diagrams are used for the installation of HVAC equipment, troubleshooting, or locating an electrical device in the control panel or within the unit. There are differences between the type of diagrams based on what they're used for. We'll jump right into showing you a schematic diagram for a simple air conditioning unit. We'll make a ladder diagram using a simple air conditioner as our example. First, we have the main electrical supply lines L1 and L2 providing 208, 230 volt single-phase power. Then we'll need a transformer to provide 24 volt low voltage power for our thermostat, switches, and relays. Next, we add a thermostat to control the air conditioner, and we connect the power from the low voltage side of the transformer to the R terminal of the thermostat. We'll need to add an indoor fan motor connection to the line voltage side of the diagram and provide contacts for turning on and off the fan. Next, we add the refrigerant compressor to the line voltage side and include contacts and a run capacitor. To complete our refrigerant circuit, we need to add an outdoor condenser fan motor on the line voltage side of the diagram. This provides us with the three largest energy-consuming devices in our air conditioner: the compressor, condenser fan, and indoor fan motors. Now we need to add some way to control these three motors, which we'll do from the low voltage side and use of the thermostat. First, we'll add a compressor relay on the low voltage side of the wiring diagram. This relay will communicate with the compressor's contactors on the line voltage side of the wiring diagram as required to start and stop the compressor. Also included are some safety devices to protect the compressor from high and low pressure conditions. This is a high pressure switch that will shut off the compressor if the pressure in the refrigerant system gets too high. Likewise, there is a low pressure switch that will shut off the compressor if the pressure in the refrigerant system gets too low. These safety devices do this by cutting off the low voltage power to the relay coil, which in turn opens the contacts on the line voltage wiring feeding the compressor and outdoor fan. We need to do the same thing for the indoor fan, so we'll add a relay coil that will open and close a set of contacts on the line voltage side that feeds the indoor fan motor. Looking at the thermostat, we can see that if we move the fan switch to auto, then the thermostat will cycle on and off the compressor and indoor fan motor. If we put the fan switch to on, then low voltage power is always provided to the indoor fan relay, which means that the fan will run all the time, even when the compressor is off. Let's look at how the symbols on the diagram relate to actual physical real-world items. This is what an electrical relay might look like without its protective cover. We have two relays in our diagram, the compressor and indoor fan relays. The relay has two main parts: the coil, which is located on the low voltage side of the diagram, and the contacts, which are located on the line voltage side. When the thermostat is on, low voltage power will be running through its wires, energizing the coils of the relays for the indoor fan and compressor. The relay coil will cause the contacts to close, which allows line voltage power to energize the compressor, condenser fan, and indoor fan motors. When the thermostat is off, the coil is de-energized and the contacts open, turning off the compressor and fans. Again, if we energize the coil, the contacts close to start the compressor and fans. We have the pictorial wiring diagram and the schematic wiring diagram. The schematic wiring diagram is also known as a ladder diagram. This is due to its arrangement of vertical lines on each side of the horizontal lines, which are comprised of electrical components. This is a pictorial representation of what the electrical components look like when looking directly at the internal control board. This lets you see where the parts are located, but it's not as useful for troubleshooting as the schematic ladder wiring diagram we just looked at. The relays are shown as blocks, just as the transformers are. This allows us to easily find them within the HVAC equipment, but doesn't give us a good way of troubleshooting a problem. Check out our industry-leading estimating spreadsheets for HVAC, sheet metal and piping, plumbing, combo HVAC and plumbing, or residential HVAC and plumbing at www.mepacademy.com. If you like that video, please give it a thumbs up and subscribe to our channel. Thank you.